Hello everyone and welcome to the Dragon Code. In this video about LIDAR, I will implement a star search algorithm to find the shortest path from starting point to destination avoiding obstacle. So let's start. Here in code I added two Python files, grid and a star. I found it in one repository on GitHub, but I couldn't find it now. But don't worry, you will have this code on my GitHub repository. Link is down below in the description. So here you have everything for a star search algorithm. It will find the shortest path. And here you have grid class, which will create grid. I only need to pass number of columns, rows, and array of obstacles. Let's go back in LIDAR Python file. I no longer need this createGridMap function to translate points because grid class will take care of it. So I will comment this, but I still need grid to find obstacles. So I need another function. I will paste it here. This function creates grid but doesn't translate points, and additionally it returns coordinates of LIDAR, which is going to be a starting point. Now I will use that grid function, so I will declare variable grid f create grid, and I will pass Cartesian dots. And because it returns two parameters, also coordinates of LIDAR, so I need to declare two variables. Next, I need to prepare parameters for grid class. I will delete this. I need number of rows. It is length of grid, and number of columns. It is length of first row. So it is grid. It can be any row, but I will choose first. And last parameter is obstacles, are obstacles. So I will declare empty array, empty list. Then I will add obstacles in obstacles list. So I need two for loops I in range from 0 to rows for j in range from 0 to columns. I need colon here. If grid I j is equal to 0, which means it is obstacles, append grid of I and j. I will append to the obstacles, append tuple with values of I and j, coordinates of that obstacle. Next, I will initialize grid class. I'll declare g variable, and then I need to include grid, import grid, as g, and from g use grid, number of columns, number of rows, and obstacles list. Because g is also variable, I will import I'll from grid, let's do this, from grid import grid class, and I don't need here G. For A star search algorithm, I need source, which is starting point. So it is coordinates 0 and coordinates 1. And I will make it visible in grid. So it is G grid coordinates 0 and 1, coordinates of LIDAR, and I will assign value 0.75. Next, I will comment this because now code is different, and paste this so it will print in terminal what are coordinates of LIDAR, and this code will draw grid. And then I will add this code. And I also need to import from A star, import A star. So what is going on here? I will ask user to enter coordinates of destination, and when user enters it, I need to check if that cell is occupied. I also made coordinates of LiDAR temporary free because of algorithm, and after algorithm is executed, I will again make it 0.75 to make it visible. So if coordinates of destination are valid, we can implement A star search algorithm. We should find the shortest path, and then I will just draw that path and all space in my room. So then when I have path, I will change all grid items where is path with 0.5. Let's now run this code. I have error here, so I will copy this and paste here. And I also need to change this 1 and 0 because first need x value and then y value. And let's run this code again. So here are coordinates of LiDAR 144, it's somewhere there, and 29, so it's somewhere there. Let's zoom it. You can see this is starting point, this is LiDAR location, this dot. Let's go back. And from here, I want to go there. So it is 23 and 75. So let's first enter value of x, 23, 75. And now path is being calculated. And here you can see the shortest path from source to destination. I will zoom it. This is starting point of LiDAR. It avoids obstacles. You can see. And it goes to destination. This is all for this video. If you like this video and want more videos like this, press like button and subscribe, and see you next time.